going to start today with slope. And that sounds really easy, but you'll be really surprised at how much trouble you have with it, probably. Okay, is my guess. This is basically grade 10 review. Okay, this is from grade 10, like all of it. All of this is in grade 10. So I taught many of you grade 10, so I learned it at one point in your life. We will be kind of talking about slope in a slightly different way, maybe. So some of the words and stuff might sound a little bit different. Slope is an incredibly important topic when it comes to calculus. In fact, calculus was basically created to find slope, mainly to find slope of things that aren't lines. Okay, so what we learn in grade 10 is how to find a slope of a line. Calculus derivatives is finding the rate of change, which is, as you hopefully know, is slope. Okay, that's what derivatives are. So slope is incredibly, incredibly important when it comes to calculus, and you really need to know these three forms, especially I would say slope point form. So I wrote over there, we have slope intercept, we have slope point, and we have general form. You should know all three really well. They're going to keep coming up over and over again. We're also going to have parallel and perpendicular lines come up constantly throughout the rest of this course. So it's like really just super vital that you are pretty familiar with what slope is. So it's given us a way to calculate rate of change. That's what calculus was sort of created for. Okay? And that's important. Like, people are like, why does that matter? But like, it's so important in our lives to figure out how things are changing and at what rate they're changing. Like money and stuff, obviously, but other things too. We're looking at like weather or like the way that agriculture is, the way business works, the way that the tides work, the way that like a lot of that stuff that like is huge world dominating forces. It really, really matters how it's changing, and calculus gives us a way to measure how it's changing. Okay, things that are really complicated. So that's what calculus is really for. And motion and stuff too, which is a big reason why calculus was invented, to talk about the way that different objects are in motion. Okay, so when a particle in a plane moves from one point to another, the net changes or increments in its coordinates are important to consider. Now this just sounds like really confusing, but all they're saying is that an increment is like how far something has moved in either direction. Okay, so how far has it moved horizontally on the x-axis, and how far has it moved on the y-axis? This is sounds kind of confusing and everything, but when you think about it, it's not. It's just talking about like a graph. Like if you had a graph, right? Okay, that's our grid. If you had a graph, that's a line. Okay, remember when you did slope in grade 10, it was all about finding those increments. We never called them increments then, but it's what it is. So if we're looking at these 2 points on the graph, we're talking about how much does it change in the y, which is y2 minus y1. That looks like y1 minus y1, but and then x2 minus x1. And that's what those increments are. All it is taking the larger number, subtracting the bigger, right? Does that make sense? It's like really straightforward. If we did have something, here, I'll just do a really simple example here. Okay. You had a point, down here, that was, let's say, -4, -2, and then you had a point up here somewhere, that was, let's say, 3, 3. Okay, if you were finding the slope of that, right, or if we're talking about the increments of this, we're talking how far has it moved horizontally and how far has it moved vertically. So horizontally would be our x2 minus x1. So our increment, if we think about that, right, that's moved 7 spaces over. Right, does that make sense? We went from -4 to +3. Okay, that's 7. Because I did some really quick math there in my head. Okay, very impressively. Okay, so x2 minus x1 would be 7. And if we did it's loud. y2 minus y1. Okay, I'm thinking of 3 to -2. That's a difference of 5. Okay, so you did this in grade 10. You calculated slope. In fact, probably did it in grade 9 even. Okay, and so our slope, right, which we are so familiar with, rise over run, is 5/7. Okay? The 5 and the 7, we are just calling them increments. This is like old news to all of you, I assume. Ooh, how do I make just this big? There we go. Okay, so the other thing, and I'm sure you've seen it before in your life, but I just want to point it out again, is this delta thing. This symbol. Okay, delta x, delta y. We're going to use those a lot. Instead of writing x2 minus x1, it's faster to write delta x. Delta, if you've taken science courses, I'm sure you're familiar with it. It's just a symbol that means change. Okay, so we're talking change in x, change in y. So if you see those symbols, it means that, it means the change. Any questions about that? Because it's pretty straightforward, I think. Right? Okay. So yeah, so calculating slope, delta x is the run, delta y is. Please put rise on top, not run. Very common mistake, even for grade 12 students. Okay, so this is our slope formula, which you are all familiar with. You've all seen it before at some point in your life. Okay, now, this is really, really important. Parallel lines have the same slope. Okay, that cannot be like, I need that to be very clear. Parallel lines, which means the lines, and you learned this in grade 10 too, two lines that don't touch each other. They keep going the same direction forever, never touch. They have the same slope. That makes sense if you think about it, right? Like if I draw two parallel lines, they're not actually going to be parallel because I'm not going to be able to draw them. But you can imagine if these two lines were perfect and parallel, they would have the same slope. Their rise and their run would be the same. They're always going up the same amount. Okay, now, that's easy to remember usually for most people. Perpendicular lines are a little bit trickier. They are opposite reciprocals of one another. Okay, so if I have one line that's like that, perpendicular to it goes the other way, obviously. Okay, so if I have one line, let's call the blue line L1 and the red line L2. Okay, so L1, if I told you, I'm just going to make it up because my line's not very neat, so I can't do it. But if I had M is equal to, it's going up, so I'll say 2/3. Okay, what would the slope of L2 have to be? -3/2. That's right. Okay, so reciprocal means the fraction's flipped. Okay, so instead of 2/3, it's 3/2. And the opposite part is really important. It becomes negative. And one has to be positive, one has to be negative. If they weren't, it obviously wouldn't be perpendicular, right? Perpendicular means that it forms that 90-degree angle. Yeah, so you've seen this before. It's nothing new, or it shouldn't be new. People tend to forget one or the other. They either forget the negative or they forget to make it reciprocal. It has to be both. You have to do both things. So those are perpendicular lines. Whereas if I drew a parallel line, it would just have the exact same slope. So if I drew a parallel line to L1, it would also be 2/3. Okay? Easy, easy. And now we're getting into the good stuff. Okay, up until now, when you have done equations of lines, you've probably preferred slope-intercept form. And most people prefer slope-intercept form. It's sort of the form that you focus on in grade 10. It's the y equals mx plus b. Everyone likes it, right? It's like great. Such a great form. However, it's kind of crappy, actually, because b, a lot of the time, is not a whole number. Tends to be something kind of ugly. In fact, most of the time, right? Because there's more decimal numbers than there are whole numbers, right? So most of the time, it's going to be a decimal. And in fact, there's more irrational numbers than there are rational numbers. So more often than not, it's going to be an irrational number, which you can't even write down accurately. Okay, so it's kind of crappy that way. Like b is usually going to be an ugly number, if we're being realistic. In your experience, it hasn't been, because your math books were created in a way where they like to make b whole numbers, or at least like nice decimals, okay, like 4.5 or something. But realistically, that's not the case. If we're just looking at situations, probability-wise, most of the time b is going to be crap. So instead, the most useful form, and this is the form you should be using. I, in the past, am like, sometimes like, I'm like, oh, like this is really what I encourage people to use, but you can do what you want. Like, keep using slope-intercept form if that's what you like. Don't. I want everybody using point-slope form. What ends up happening is there's like a couple weak students who just like are like, I'm going to stick with slope-intercept. And then they are really bad at everything, and it becomes really difficult for everybody. So instead, I want pretty much you to be constantly using point slope form. Don't worry, I'll teach it to you. It's not that hard. It is a grade 10 material, so everyone passed grade 10, and I know you're capable of doing this. If I didn't teach you grade 10, you may not have really seen it, because I know some of the grade 10 teachers kind of skip over it, because they don't think it's important, but it's going to be important now. So this is called point slope. This is the form of it. Y equals m, so m is slope, just like we're used to, times x minus x1 plus y1. So the only difference between these two forms, if you kind of look at it, is it's just the difference between, next to the x, there's the subtract x1. Now what this is that x1, y1, I mean it's explained underneath, but just to be really clear, x1, y1 is any point on the graph. So this graph that exists is going to go through some point eventually that's a nice point, like a point with whole numbers that are nice. Okay? So this could be any point on the graph. So you can actually write like endless possibilities for this for any graph. Like if I drew a graph, I could write infinite different point slope form versions. I just pick different points. The slope's always going to stay the same, but any point on the graph is going to work. And if I convert this, like if I expand this out, if I take a minute and expand it and add it together, it will give me slope-intercept form. Okay? So it's the same, it's just a different version of it. Okay? They're equivalent. Okay? So let's just look at how it's used. It's really nice. So write the point slope form equation for the line going through the point 2, comma 3 with a slope of negative 3/2. So this is a situation where in grade 10, if you didn't learn point slope, this becomes a very difficult, well, not very difficult, but for grade 10, it's a very difficult question. They have to plug this into x and this into y, and then they have m, but then they have to solve for b, and you have to get b, like it's a whole big rigmarole. Or you can just use point slope form. Point slope form is great. Like as long as you can see one point on the graph, you can use point slope form. This one, we don't have to see it because they just tell us, but it's awesome. So I just fill it in. So I'm like, okay, y equals, what will I put in for m? Negative 3/2. So I put that in for m. Now x is always just x. Don't put anything in for x or y. Okay, just leave them. Okay, now x1 is the x coordinate of my point. So x1 is 2. So all it is, it's minus 2. Okay, and notice it is minus 2. It's not plus 2. If this had been negative 2, then it would be plus 2, because it would be minus negative, which is a plus. It's similar to transformations if you've done Math 30-1 already, where it's the opposite of what you're expecting. But it's easy to remember. Same thing with vertex form in Math 20-1, so all of you have taken that. This is always the opposite. Okay, so it's negative 2, because it's positive 2, and then it's plus 3. Okay, cool, and that's it. That's everything. We're done. And in this course, like most of the time, this one says point slope equation, but a lot of the time it'll just say equation. This is an equation. You don't need to simplify this. Okay, there's like basic, unless I specifically say slope intercept, there's no reason to expand this out, like ever. So don't, just leave it. Okay, like this is last step, unless I say slope intercept. If I did say slope intercept, you would have to go like that. You'd get negative 3x plus 3, and then you'd have to add the 3. So you'd end up with plus 6 at the end. Okay? And you'd end up with negative 3/2x plus 6. Okay? So that means that the y-intercept for this is 6, which is a nice number, which tells you that somebody made up this problem to have it be a nice number. Okay? But that's it, really. So don't expand it unless you're asked specifically. That's just extra work. Okay, so this is our slope-intercept form. This is the one that everybody loves so much. You might have to use it from time to time. Okay, so if we were doing slope-intercept form here, because it asks us to, okay, I am given 2 points. How could I figure out what my slope is? Look at the difference between the 2 points. So what difference do I look at first? No. Slope is rise over run, so we should look at y's first. And it doesn't matter what order you do it in. I mean, it matters what order you do it in. You have to do y's first on top. But it doesn't matter what order you put the two y's in as long as you stay consistent. So you could do 4 take away -1, or you could do -1 take away 4. They're both fine. Okay, just be careful, please. Be careful with this stuff. It's really easy to make little mistakes. One of the fun things about calculus is you're not going to have your calculator for a lot of it. So get used to doing this stuff in your head. Okay, 4 take away -1. And then 3 take away -2. So just see, like, I'm being consistent here. I started with the 4, so on the bottom I start with the 3. Hey, you did this lots in grade 10. It's been a while, but you did it a lot of times back then. Okay, so 4 subtract -1 is 5. 3 subtract -2 is also 5. So here my slope is 1. Okay, this has a slope of 1. How nice. Okay, now to figure out b, there's a couple different ways you could do it. You could do it by plugging in either one of these points into x and y and doing it that way, but I honestly think the easiest way is to use slope point form. Like that slope point form that I showed you on the other slide is super useful. You should be using it. You should know it by heart for sure, so using it like all the time in these kind of situations is probably a good idea. Now, it does not matter which of the points you pick. Okay? It doesn't matter if you pick 3, 4, or -2, -1. They both will give you the same answer. I would pick 3, 4 because it's positive. So why make my life harder than it has to be? So I have y equals 1. You don't have to write it in, but I'm going to just for the notes. Minus 3 plus 4. Normally you'd have to expand this, right? But it's a 1, so really I don't have to, but let's just pretend. Okay, so I have x minus 3 plus 4. And then all I do is I add these two up together. So I get y equals x plus 1. Hey, yay, there we go. That's slope-intercept form. Okay, that means that 1 is the y-intercept. It's a very easy process. Really, I would expect most of you to do it in just one step. Like, just do it, like, right away. You don't need to show me a bunch of steps. Now, otherwise, if you didn't want to do that, if you were like, I don't like that form and I'm just going to do it my own way, the way you would do it is you would take y equals mx plus b. You would plug the 1 in, and then you would also take one of these 2 points, probably the 3, 4 again, and you'd plug it in. So I'd plug 4 in for y, 1 in for m, 3 in for x, plus b. So that's the same thing as b plus 3. Then I would subtract 3 on both sides. Subtract 3, subtract 3. So b equals 1, which is what I figured out before. And then I'd have to put it in. So I'd be like, okay, so y equals x plus 1. Okay, same way. Honestly, I think it's longer. It is longer. I think it's like unarguably longer. It takes more steps. People mess up in stupid ways on it all the time. The other thing that people do all the time is that they just stop. Like they get b. They're like, b equals 1, I did it. Because people really like having that equal sign. But b equals 1 is not slope-intercept form. It's just the intercept. So it just kind of like people stop before they're finished. Yeah, I just think it's better to do it the other way. Plus, it gives you more practice with point slope. So, and finally, okay, general form. Everyone did learn this one, but you might have seen it slightly differently. And you know what? Sometimes it is slightly different. Like there's 2 different ways that people do general form. The other way a lot is where it looks like this: ax plus by plus c equals 0, like that, with a c on the same side. They're both fine. Like either one's fine. Whatever you feel more comfortable with. You would just subtract c from both, right? Like you would just move it whichever way you want. But there's some really important stuff here, and it's actually not even written down here, so I guess I should probably like write it down for you guys. Is that a, b, c, it first of all says a and b can't both be 0. That's important. Okay. Also, a, b, c are all supposed to be whole numbers. Okay, they're all whole numbers, and a is positive. So I guess actually I should have said are all integers, and a is positive, but you know what I mean. Okay, there's no decimals, there's no fractions in this form. We don't use this a ton. What happens most, like I would very rarely ask you for any if ever, ask you for an equation in general form. But what happens more often is that you're given an equation in general form, and then you have to work with it. So like in this case. So they give you the equation. They're like 8x plus 5y equals 20. Graph it, find the slope and y-intercept. So you're given this equation. You need to switch it into another form. You cannot switch something into point slope form. Like you can't go from general to point slope. It's impossible because you don't know which point, like there's an infinite number of point slope forms. You don't know which to use. You don't know which one you should use. So you're going to have to go slope intercept. That's the only way to do it. So how would I take something like this and change it into slope intercept form?
Isolate y.
Isolate y. That's it. Don't overcomplicate it, right? Just isolate y. So just using your algebra that you are so good at, isolate y. So I subtract, what would I do first? Subtract 8x, that's right. So I subtract 8x from both sides. Okay, no problem. So I get 5y equals negative 8x plus 20. And notice I just put it in order right away. Like I know it's going to be mx plus b, so I just put x's first. Then how will I get that y by itself? Divide by 5. So I just divide by 5 on both sides. Now here, this is the only part that people sometimes get mixed up with. You do have to divide everything by 5, like all the terms. So I end up with y equals, and don't turn this into a decimal, please. Like leave it as a fraction. You really won't, you shouldn't be using your calculator right now. And it's easier to work with a fraction when you're dealing with slope anyway, because it's rise and run. So it's negative 8 over 5 x plus 4. So if I graphed this, and I'm certainly not going to do it very neatly, but if I graphed this, right, old school, I'd go through 4 on the y-axis, and then I would go down 8 over 5, down 8 over 5, and I would connect them like that. Okay? And there we go. That's graphing in a nutshell. You're not going to have to do much graphing, really. So mostly the algebra is what we're going to be doing, which I assume most people will like better. Hey, does anyone have any questions about that one? It's pretty easy, right? Everyone's done this before. It's not new. Okay, now these ones I'd say are the most important. This is the last one I think I'll probably do. I'll check what's next after. Actually, maybe I should. No, I'll check what's next afterwards. Okay, but this is really important because this is what you end up doing in calculus all the time. Like eventually you're not just finding slope. You have to like find a derivative. But once you find the derivative, you're going to have to do this. They're going to ask you, like, now what's the equation for the parallel line? And what's the equation for the perpendicular line? So it's just really important to know how to do it. It's not super difficult. Okay, they gave you, and we did it in grid 10. They gave you this line, y equals 3x minus 4. They tell you a specific point they want it to go through. So they want this line that you're creating, the two lines you're creating, to both go through negative 1, 2. And you want one that's parallel and one that's perpendicular. So let's just kind of imagine this situation before we get going on it. Okay, so 3x minus 4, that would look like it's minus 4, so it's somewhere in the negative. And it's 3x, so it's going up, and it's like kind of steep. Okay, so that's sort of what that line looks like. That's L. Okay, now if we look at negative 1, 2, that would be like somewhere over here, right? Okay, that's that point. Somewhere over there anyway. Now, we want one line that's parallel. So one line that just looks exactly like this line but moved up to there. So it's like, right? Like just like parallel to it. Okay, then another line that is perpendicular. So another line that's like that. Okay, that's that way. And we want the equations for both of those lines. Easy enough. Okay, it's really not that bad. So if we're doing this, we just go A parallel. What will my slope be if I'm looking at a parallel line? The same. So what will it be in this case? 3. So my slope is 3. And I know it goes through negative 1, 2. So that means that y1, x1, y1 is negative 1, 2. So my equation, is y equals 3x plus 1, because it's the opposite, plus 2. That's it. Okay, that's the whole equation, Conrad.
Couldn't you just change the -4 to like +1 and also have it earlier?
If you figured out that it would be going to +1, you could. But is it?
Well,
Like, I feel like
just move the line up to like.
it would make the y-intercept 1 if you did that.
Oh, okay.
Here, the y-intercept would actually be 5. So no, you couldn't do that. You'd have to figure out what the y-intercept was. If you wanted to do that, if you wanted to but it's way harder. Don't do that. But if you really are a super graphical person and you're I can tell what the y-intercept's going to be, you can certainly do that. But this, I wouldn't expect you to write this down every time, this stuff. That's just for the notes. You really can just write the answer. I want this to be second nature. I don't want it to be something that takes 6 steps. Okay, so for B, the only thing that changes, because it still goes through the same point, the only thing that changes is the slope. What's my slope going to be if it's perpendicular? -1/3. So my equation is exactly the same. It's just -1/3 x plus 1 plus 2. Okay, so the only really important thing here that I don't want anyone to mix up on is that it's -1. So my equations are +1. Okay, just the opposite. Okay, but it's pretty straightforward, and please don't mess with it from here. You don't need to change it into anything. That's it. And yeah, you're gonna have to do this a lot later on. So just getting familiar with it, being comfortable with it, is a good idea for everybody. Okay. Oh, and regression. I guess we should go over regression. Everyone, pull out your graphing calculator. Fully charged, ready to go. Does anyone not have one today? I need to borrow one. Anyone else? People are leaving. We're gonna wait for them because this is complicated. Yep.
Thank you.
No problem. Hey, try to bring your calculators to class. But I know it's the first few days here. We're all forgetting things. Okay. I am going to wait for Sean to really get into it, but we're going to be doing something called regression. It has a lot of steps to it. It's going to seem like, the first time I show it to you, it's going to seem like a nightmare. You're going to be like, why do I have to do all these steps? It's terrible. But it's honestly, if you do it a few times, it's really easy. It doesn't take very long. With linear, this is a linear model. It tells us in the thing, right? It says build a linear model. You can do it without the calculator. It's but the cool thing about graphing calculators, one of the cool things that they can do is if you have a bunch of data and you tell it what sort of data it is. So if you tell it it's linear, or it's quadratic, or it's cubic, or it's sinusoidal, or it's exponential, or it's logarithmic, if you tell it these things and give it data, your calculator can spit out an equation for you. Okay, so which is kind of cool. It's a cool thing it does. It does take some button pressing to get to that. 30-2, they do it a billion times, so I'm really good at it because I've taught that course. But I never used it myself other than that, to be honest. But there's the odd question, very odd question that uses it. However, in the pre-calculus unit, to be honest, it's a really easy point. So if you know how to do it, it's there would probably be 1 or 2 questions on the test that involve it. They're really easy points if you just learn the buttons. So everyone press on your calculator, stat, edit. Okay, now you come up with a list. Okay, it says L1, L2, like this. What I want you to do is just enter the data in as it looks under that. So enter 1980, 1985, 1990, 1995, 2003, 2004, 2005 under L1, and enter the other numbers in L2. Okay, so that's in stat. I'm gonna write it down. Stat edit. I think I do have a video of myself doing this, so I might just post it too on the classroom. But try it out. Stat edit. Once you get all the numbers entered, I'm used to just doing it, not just like listening to me, because it's just one of those things, you know, you learn by doing. Okay, so once you do that, you press stat. You go over to calc. And I don't know what option it is, number 4, yeah. And use number 4. Hey, use number 4. Does everyone have a fairly new calculator? Is anyone using like a TI-83? Everyone, good, perfect. Okay, so once you get that up, something comes up where it, actually I might have to look at someone's, exactly what it looks like, but, right, you end up with this list of options. So it says X list L1, X, Y list L2, that's what it should say. Now where it says store regression equation, store regression equation, it says something like that, that's what it stands for. What you do is you go down to there, and you press alpha F4, okay? Yep. Alpha F4, and you pick Y1. Okay, I'll show you guys on my screen after this, so if you get lost, don't worry. Okay, then press enter, enter, and it'll spit out an equation at you. Okay, so I'll show you guys again on here. So I enter all this data into here. Close. Hey, I was obviously doing something here. You should all get the same thing because you entered in the same data. Okay, if I entered in here, yeah, if you make a typo, it messes everything up. So don't. You should see the ones they have to do in 30-2. It's insane. They have to enter in like 60 data points. Okay, guys. Okay, so everybody just look up at the screen. I know a lot of you figured it out already, but just to show you kind of again. So you press stat, you go over to calc. Okay, this is all the lists. So if you were given a bunch of data and it said somewhere it was quadratic, or it said it was sinusoidal, or it said it was logarithmic, or whatever, that all those options are here, and you can just tell it what it is, and it'll spit out an equation for you. So here, it's linear, like we're told, so it's number 4. Comes up with this. The only thing you should need to change is this. Now the reason for this is really just for handiness. Like if I press alpha F4, just a shortcut to get to Y1, what that does, and the reason why I have people do it, is because it automatically inputs whatever equation you get into your graph. If you don't do that and you want to work with this equation for some reason, like say you're trying to find something from it, you would have to type it in yourself. So it's just easier if you just put it in right away. So when I press calculate, it spits out the numbers. So my slope here is just about 80. and my B value, my intercept, is negative 153,000. Okay? Now, so if I go in and I press y equals my graph, look, it's already in there. Okay? Because I put store y1. Okay? Now, zoom, there is a special zoom here. If you press zoom 9, it'll bring you, oh, maybe not. Okay, well, never mind. But if you, I guess you can change your zoom to what you want. Here my x values are from like 1980 to 2005. So if I just change this to 1980 to 2005, like thinking about your x values, right? Like if I think about that, look at the chart. The lowest number in the x column is 1980. The highest is 2005. Getting good at manipulating these tables is very helpful. Okay? Then if I go down to the y, what's the lowest y value for my tables? What's the lowest number in the second column? Yeah, 4,454. So if I go like 4,000-ish, it doesn't have to be exact, right? The highest is 6,450, so if I go like 7,000, okay, now I'm going up, that's like 3,000. The scale technically doesn't matter, but like, I wouldn't really want to count up by tens when I'm doing that. Maybe if I count up by 500s or something. Okay, now I can see my graph there, and I could mess around with it. So for instance, the question here, use this to predict the world population in 2010. Well, right now my graph's only going up to 2005, but I could change it to like go up to 2020. Okay, now my graph goes up to 2020. I could use this to figure out what the population is approximately going to be in 2020. All I have to do is go trace 2010. Trace 2010. And there it is. Okay, it's about 6,865. It's right on there. Okay, so it's knowing how to use your calculator. Now the other question here was predict when it would be 6812. To do that, you're given a y value. The only way to do it is to put it in underneath. Okay, 6812 in y2. And what would I be looking for here? The intersection point. So I go second trace 5. Don't worry about knowing all of this right now. We will do more of these. I'll do like just some basic regression practice. It says 2009, so around 2009. This, once you practice it a few times, is extremely easy. It's just this, when you first see it, it kind of seems hard. And I'll put a video up of just me going over it so that everyone's on the same page. Okay, so there we go. That's how you do that. Pretty easy. Now these things where you see that I have homework listed, I'm not going to mark it. I'm not going to give you time to do it. These are the suggested questions to do in the book if you need extra help. Okay? If you finish all the work I give you in class, this is a good thing to do in the evening if you end up coming to night class. Okay? Just so you know. Yeah, I did pick them out as being important ones to look at.